And hello, I'm just making a note now of how to do read and write variables, but I have a polling action do it every few seconds for me. So one example I have done is basically if I want to convert from pounds to kilograms, okay, I will have one variable representing pounds and one variable representing kilograms. So this is more or less the same code I did before. I have a read-only variable and a writable variable. My read-only variable is the mass in kg. My writable variable will be the mass in pounds. So how I intend to use this OPCUA server is to input the mass in pounds and then convert it to kilograms. Now the code to do it is over here. So basically, I take an address space. I get the node, the node number. I write. I get the variable value using this get variable value function. I convert it into a float 64 using this series of functions here. A lot of unwraps to do. Okay, then I multiply it by 0.454 because the kg value is the pounds value, the value in pounds times 0.454 approximately. So 1 kg or 1 pound is 0.454 kg roughly. Okay, and then I set the kg variable. So this is just something I copy and paste. All right, I just copy and paste this basically from a little bit. Yeah, you see the simple server code. Yeah, I use this set variable value thing and I kind of just copy and paste it over. Okay, so let me show you how it works. So I'm going to start running this in my main.rs. Okay, example 6 read and write variables, and then this will run the server. So it's under my Rust OPCUA server. Now I'm going to start up my OPCUA client and I'll connect it to that address. Okay, so it's already gotten my address. If not, I can use that function that's very handy. I can just copy and paste it over. And let me connect and demonstrate. Okay, so here is my mass in pounds, and here's my mass in kg. So the mass in pounds is the writable bit, the mass in kg is the not writable bit. Okay, so how do we so-called do this? We will just we will take the mass in pounds. So now it's 0 mass in pounds, and it will be converted to a mass in kg. So let's say I have 10 pounds. 10 pounds in kg will be 4.54. Now if I add both of these to the graph, it will be as follows. And I can of course apply get it to update every 1 second. So if I change the mass in pounds to 35 pounds, I can get the mass in kilograms, which is approximately 16 kilograms. So or 15.89, whatever, you know. So this is a nice, you know, converter, but it serves as a template of, you know, how to get functions that make functions or I mean, it's a simple example of how to get the closure which takes this value here, which is a mass in pounds, turns it through a function, let's say just times a conversion ratio, or you want to do something more fancy with it, and then converts into a mass in kg. So that's what it's doing. Okay, so I'm going to start from where we left off the last one. So I'm going to disconnect from this server because the example 6 is just to demonstrate how demonstrate that I've done it. I'm going to comment this out, and what I'm going to do is yeah, I'm going to make a new what do you call that, make a new Rust code. I'm going to copy this and I'm going to call read and write with closures .rs. Okay, so this one is called read and write with closures, and then I will have my example 6 here. Yeah, and I'll write all. Okay, so as usual, I will just put this into the module pub mod read and write variables with closures, and I'll include this inside my main function. pub use live demo, read and write with closures. Put star, and then of course I'll put this here as demo 4. Okay, this will be demo 4. Read and write okay. I didn't even spell variables properly. But okay, read and write with closures. Read and write variables. Okay, so let's just get it done. Okay, so how do we do it? Okay, so first thing first, we need the, if you take a look here, we need an address space. We need to write to an address space. This is very similar to the way we just do things here. We have an address, we get the address space and some node ID. So let me do an example of Fahrenheit to degrees C converter. So if I have a Fahrenheit to degrees C converter, I'll have a temperature in Fahrenheit, and then I'll try to convert it to a degrees C. So how do we do it? Well, I will have my read-only node. Okay, this read-only node will be here, and then I'll change the read only to Fahrenheit. Okay, and then I'll do the same here. Sub read only with Fahrenheit globally. Okay, so this is how we get the I'll just make a Fahrenheit node here, and this writable node I want to change it to degrees Celsius. Okay, and then I'll change it to degrees. Oh, I wanted this to be Celsius. Okay, read only. So read only is the result. Celsius. G 20 down. Read only with Celsius. Okay, and then here the writable, I will just substitute it with Fahrenheit. So this is a conversion. So writable Fahrenheit. Okay, so it's a Fahrenheit to Celsius converter. That's how this is supposed to work. What I'll do is, of course, I will get example 6, or rather the live demo 4, right, with closures, and I'll do the run server code. Okay, so this server is running, but it's not really doing what I want yet, but at least the variable names should have changed. So I'll just log into my demo server. I'll connect here. Okay, under my objects, I will have the read only, and I have Celsius, and the write only is the Fahrenheit. So that I can change the Fahrenheit to what? Maybe 52 degrees Fahrenheit. It will change the value here, and ideally I want the Celsius variable to be swapped to reflect this conversion. Okay, and of course the graph I don't really want anymore. I want a new graph, but for the time being we just leave it like that. You now have to close and open again. Be kind of little extra things to do. Okay, so yeah, this is how we I have a Fahrenheit and a Celsius node. So what I want to do is maybe add a closure that converts Fahrenheit to Celsius. So let convert F Fahrenheit to Celsius. Okay, equals to, I'll just make an empty closure here, move, and I'll have the open and close curly brace with the semicolon. Okay, first thing first, let's just get our address space. So we always need that. let mute address space equals to address space, right? So this mutable address space is a local variable, so maybe I'll change this to local because it will disappear after the closure. All right, then what I want to do is to find, okay, so we are setting Fahrenheit, right? We're setting Fahrenheit, and then we want to convert it to Celsius. So let's read the Fahrenheit node first. Read the Fahrenheit node. So how do I read the Fahrenheit node? Let Fahrenheit node equals to, okay, well, we first find the correct node object. So I'll find the Fahrenheit node and I'll clone it. Fahrenheit node clone. Okay, where did I get this step from? Okay, this step I actually just copy and pasted from here. If wait, here. Wait, hold on. All right, it's over here. It says over here, if let sum reference mute v equals to address space find variable mutable. So I didn't actually copy from here, but I took inspiration from here. So this one, it says it's finding some mutable variable, and what you need is a clone of the node. So you see, so instead of writing all these commands within one chunk of code, I'm separating out so it's kind of easier to read. Okay, so first thing first, I'm getting the Fahrenheit node. So I clone the Fahrenheit node, and that's the innermost thing. And then I need to plug it into a address space to find the variable. So this is what I'm going to do. Yeah, this one actually finds the variable, but there's an easier way, which is to get the variable value. Okay, how do I know? Okay, so let Fahrenheit variable equals to what? The address space, the local address space, in fact. Okay, so address space will have a lot of what do you call it? A lot of functions. So I can actually scroll through the functions, and if you see this thing, it says what? Oh, we can actually get the variable value. That's one way of looking at it. And the other way is that, okay, so you see this address space here, it actually has a set variable value function. So you kind of infer that if there's a set variable function, there should be a get variable function as well. So this is where I kind of guess, okay, we can get variables. So these are two ways you can find out, but okay, I'm just going to use a get variable function. Okay, and it's requesting a node ID. So what's the node ID? It will be the Fahrenheit node. So instead of doing all of these, this is a different method. I just get the variable value straight. I'm not interested so much in the node. Okay, so this is the Fahrenheit variable, and I want to convert it into a float 64. So this is step 3. Okay, get Fahrenheit. Okay, so this is step 2, get Fahrenheit variable. Oops, undo. Okay, get Fahrenheit variable, and this is step 2, and this is step 1. So step 3, let's convert it to a float 64. Step 3, convert to F64. So I already know this is a float, so it should be fine. Let Fahrenheit value, I'll strongly type it as a F64. So let's get the Fahrenheit variable. And what do we do? Okay, what do we do with the Fahrenheit variable? So we can do this, and you see most of the methods here have to do with unwrapping. So we need to just unwrap the thing first, because it's contained in a result enum. Okay, then what's next? Okay, we see that the first thing we have, first the field we have is a value. So we can just take that field. Okay, and then once we have the field, what can we do? Okay, we take a look at this. You see there's an unwrap enum down there, so we can just use that unwrap. And then what's next? Okay, we see a few methods here, like into, try into, so on and so forth. And one good thing is that we have a f64 method. So that's very convenient because we want to convert it into f64. Okay, so since we have the f64 method, we'll just convert it. And this actually needs to be unwrapped as well. So that's how I'm getting it. Okay, so you just convert into f64. Okay, and last one is to set the Celsius variable. Okay, but of course I need to convert it into Celsius first. Convert to Celsius. So what do I do with Fahrenheit? I need to, I think, subtract 32. Or is it plus or minus 32? Okay, let Celsius value f64 equals to Fahrenheit value, okay, times 5.0 divided by 9.0. Or is it minus 32 first? I need to minus 32.0. Then I kind of do the multiplication bit. So times 5.0 divided by 9.0. Okay, so this is the Celsius value, if I'm not wrong. I have to go and check again. So we just do a sanity check here. So Fahrenheit, if it's 32 degrees Fahrenheit, we should be having the freezing point of water. So 32 minus 32 is 0, times pi over 9 is 0. 212 is the boiling point of water. So 212 minus 32 is 180. 180 times pi over 9 is 100. So this is the correct formula. Okay, so last part, let's write this value. Set the Celsius variable. Now, note that we actually, for the Celsius variable, which is over here, okay, the Celsius variable is a read-only variable, but it is writable by the program itself. However, you cannot write it from the client side. So the read-only only applies to the client side. It means that the client can only read this variable, but on the server side code, you can actually modify this variable as and how you like. So the way to do it is to use the datetime_now method. And how I got this is basically copy and pasting these two lines of code here. This is the same. Okay, now equals to datetime_now, and then you let this address space equals to whatever. So basically, I'm going to show you this. I just copied this code, and what I did is that I pasted it here. Let's see, equal sign. So the let datetime_now equals to now. Set the variable value. So what do we set it as? We set the variable value to not the v1 node. So this is, we are looking for the Celsius node. So Celsius node, we clone it. And then we want to set the variable value to Celsius value, okay, as f64, just to make sure. And then the last two pointers are just now and now. Okay, so it says no, nothing that is called set variable value. Okay, so I need the writable version of the address space. So this is the address space local. So I need to change this to address space local. Okay, and there we go. We have the convert Fahrenheit to Celsius closure finally done. So I can say I think we are done. Okay, just like I wrote here. So the next thing is to just load this thing in here. Okay, so importantly is that you cannot use any reference or you cannot use any server objects in here, but you can use the address space object. You use the address space objects in here in the closure, but you cannot use the server space object. Because if you try doing that, okay, let s1 equals to mute and mute server, you will get an error. It says the value is moved, so you cannot actually have mutable references to the server directly in here. So this is something you cannot do. That's just a cautionary note. Okay, so next thing, I'm just going to add the polling action to the server. So add polling action means, okay, I'm going to run this conversion action every few seconds. So I want to run it maybe every 300 milliseconds. I think that's fast enough. And then the function or closure I want to use is convert Fahrenheit to Celsius. And hopefully this thing will run well. Okay, so when I look at this, okay, it's run properly. And let's check out whether it works. Okay, disconnect and connect again. So we have a Celsius variable and a Fahrenheit variable. So you see the Fahrenheit variable is writable. The Celsius value is not. So I'll try adding these to graph. Okay, so both are now at 0. Okay, oh, in fact, the Fahrenheit, let me see view all. Yeah, you can't actually see the Fahrenheit variable very much, but 0 Fahrenheit is minus 17 Celsius. So let's do the freezing point of water again, 32 Fahrenheit. And let's check out the Celsius variable is 0. You have 212. Okay, the graph isn't updating very well. So sometimes I like to just restart and do everything again. But this is the boiling point of water, 212 Fahrenheit. Celsius shows 100. So thing works. Okay, so this is important, I guess, if you want to do stuff with it. It's good to have this conversion function, or it just shows that you can use these closures to modify the variables according to what you want, and this can be run every few seconds with a polling action. Of course, there are other ways of doing it. For example, you have these getter functions. You have these getter functions which kind of look complex to me, but that's not what I'm going to use. I'm just going to use these polling actions to get the variables every now and then. Of course, the downside is that, okay, it's not as responsive as the function, so to speak, and you're kind of waiting every second in order for this to happen. But okay, for some purposes, it's enough. Yeah, I think that will do, and I'll stop the video now.